file1.c, and you have file2.c, right? Okay? And now suppose the file1.c declares an integer x, okay? A file scope, okay? Who can use this x? This is not inside any functions, it's just inside the file. Can this file use x? Yes.
Yes.
Right? Can this file use x?
No.
Oh, yes, it can. This is a global identifier, and it can be used in another file. But what does this have to do? Let's see how well really you know. See.
Include.
You have to include. Well, suppose you're not including.
Extend.
Who said extern? Thank you. All right. So you have to use an extern declaration that essentially tells the compiler, hey, there is an integer I that I'm using here, but do not allocate space for this because someone else has allocated space for this. You know, when the linker gets through the code, it will actually link references to X. It will create, a link from, each reference to X here to the X that was allocated by file 1. That's a declaration. It does not allocate another copy of X. Okay? All right? Yes?
To use extern, doesn't file 1 output the same in the same directory?
Huh?
To use extern, don't both files have to be in the same directory?
No, not necessarily. As long as you have the right paths, set up.
The linker should take care of that, right?
Huh?
The linker should take care of that?
Yeah, the linker, yeah. When you link the files, you have to specify the correct paths.
What if there is no variable of that sort? If, for example, file 1.c is deleted, what happens?
It would be a linker error. The compiler will compile, but basically you fool the compiler into thinking that there was an integer x allocated by someone else. When the linker goes and tries to find somebody who has defined that x, it doesn't find it.
Okay,
so the compiler, essentially the compiler creates a table, okay, of symbols that are either defined here and used someplace else, or used here and defined someplace else, and it looks at all the tables, okay? So if you said, there was an externally defined integer x, it will look at all the tables, okay, of a file. So if it doesn't find one, okay, then it will flag an error. It will not generate, an executable image. Okay,
so,
yeah.
What if there's one more file 3.c, and having the same int x? Then where will it go?
If file 3 has int x,
yeah,
it's a multiple definition error. Again, it's flagged by the linker. Okay. All right. Did I finish this one? Oh, no. I was forgetting this, very important. Okay, the scope of an identifier versus the lifetime of an object. This is something that, again, can be a little confusing. And the reason is, people use the terms interchangeably when they're not interchangeable. The scope of an identifier is the region of text over which the identifier is defined. Okay? So for an identifier like a local variable inside a function, what is the scope of an identifier? Huh?
within the function.
Within the function. So the entire text of the function, from the point where the identifier is defined, all the way until the final curly brace, right? That's the scope of the identifier. So the scope of the identifier is a compile time thing, okay? It exists in the source code, okay? When the source code goes away because the compiler has transformed it into object code, that doesn't exist anymore, okay? The scope of the identifier. The lifetime of an object is an interval of time during which the object exists. It's between the allocation of space for that object and the time when the object is deallocated. Okay? All right? So this is a runtime concept. It exists, for when the program is executed, and it involves, when, does the object exist. So, in this case of this int I defined in function foo, what would be the lifetime of the object bound to I? I is referred.
By the time of the function.
Till the function returns.
Right. Well, when the function returns, it dies, right?
Yeah.
When is it born?
When the function is called.
When the function is called. So the lifetime of this object is every time a function is called. Between the time a function starts execution until the time when the function ends execution. That's the lifetime of that object, the object bound to I. All right? And the reason why we confuse scope and lifetimes or extents is that oftentimes the two concepts are related. What is the scope of a global variable? Well, you're all object-oriented programmers, so you don't know what global variables are, right? Yeah. Right? No, seriously. It's another thing that got lost in our job.
In the entire,
Huh?
in the end of execution of the program.
The entire source code, right? The global variables is visible everywhere, right? Okay? Remember, the scope is a piece of program text, right? So if it's a global variable, its definition is visible everywhere, okay? All right? What is the extent of the object bound to a global variable?
Start to end.
No, it's the entire program execution, right? The variable starts existing when you load the program into memory, and then it will be around until the program returns. Exits, right? So often the two things go together, right? In the case of a local variable, in a function, yeah. No.
Right here.
Oh, there. Thank you. But let me throw a curveball at you. Okay, now I have a special variable in my function foo that I declare static. Okay, what is the scope of this identifier I?
Global.
Global. You think if I'm here I can use I?
No.
Oh, okay. So the scope is the function itself. From this point, from the very point where you cannot use the identifier before it is declared in the function, but you can use it after, okay, right? Until the end of the code. And what is the lifetime of the object bound to the identifier I?
End of the program. End of the program.
End of a program? Well, that's when it dies, right? When does it start living?
Once it's initially called, and then the lifetime is sorted.
No.
When the function is called for first.
Yeah.
No, it actually exists for the entire execution of a program. It's allocated in static space. Yes. Okay? So here is an example where there is a discrepancy between the scope of the identifier and the lifetime of the object. Okay? This identifier is only visible locally inside the function, but the object exists for the entire duration of the execution of the function. Do you all know what the static identifier is? Right? It's one that remembers its value across function invocations. So, if you assign 3 to I, when you return the next time you call foo, it will remember it was 3. Okay? All right? And so these objects have to exist all the time. They cannot just go away when the function returns because they have to retain their value across function invocations. And so they're allocated in static space. Yes?
Can you call I outside of foo since it's static or no?
No. Because the scope determines the visibility where I is visible. All right? So the two concepts are different. Okay? I have 2 more minutes, so let's see. Static versus dynamic scoping. This is kind of a big topic. Maybe I'll start it today. Static scoping means that the scope of an identifier is determined only by the source code, by the structure of the source code. Okay? And so, I was discussing scope earlier. I was saying, for this identifier I, the scope is from the point where I is defined all the way to the end of a function that contains the definition of I. That's an example of static scope, okay? This means that I is visible in this portion of the code and nowhere else, this I. Okay, someone else may define another identifier I, but that would be a different object, okay? All right? Okay, And in languages that are statically scoped, this is always true. You can look at the source code and always say what the scope of that identifier is. Okay? All right? The typical example of static scope rules is lexical scope based on nesting of units within units, which essentially says the scope of an identifier is the entire unit when it is defined, except for inner units, inner definition, redefinition of the same identifier. So for instance, if you have a class C that has a field I, okay, all right, this definition extends over the entire scope of class C, except that there may also be a method foo inside that class that has an integer parameter I, right? So we say that the scope of function foo is nested inside class C. So inside method foo, the innermost definition takes precedence over the outer definition. Okay? So as you nest units within units and you redefine the same identifier within those units, okay, the innermost definition takes precedence over the outer definitions. Okay? This is the basic idea of static scope rules based on lexical scoping of units, based on nesting of units within units. With dynamic scope rules, the scope of an identifier depends also on the runtime program behavior. And the place where you see this difference is when you are referring to an identifier that was not defined locally. Okay? Say that foo here does not redefine I and uses I. Okay, so I is, a non-local definition as far as foo is concerned. Okay, in the case of dynamic scope rules, a reference to a non-locally defined identifier is resolved in the context of a unit that invoked this unit, and that can change at the runtime. Okay, and we will see an example of that next time. For today, I'm running out of time. So let's stop here. Do you have any questions?